Hello friends, today's video is about Arithmetic Progression, Class 10, as per NCERT syllabus. And it is a full concise course. First we begin with the definition of an arithmetic progression. Then we will see general form of an AP. Number 3 topic is about, say if a sequence is given then how to check if it is an arithmetic progression. Number 4 we cover important formulas in this chapter. And then we derive those formulas. These include topics 5, 6 and 7. Topics 8 and 9 handle with different types of problems for 100% understanding of the chapter. What is an arithmetic progression, in short, AP? An arithmetic progression, AP, is a sequence of numbers in which the difference between any two consecutive terms is constant. This constant is called the common difference, denoted by D. Let us see general form of an AP. Assume that the first term is A and the common difference is D, then the arithmetic progression sequence is A plus D, A plus 2D, A plus 3D, and so on. The nth term or general term of an AP is An is equal to A plus into bracket n minus 1 D. Here n is greater than 1. Now let us see some examples of an arithmetic progression. Here is first example. The value of first term, that is A, is 2. If we add common difference to first term, then you get second term. Here common difference is 3. Hence 2 plus 3 is equal to 5. Similarly, by adding common difference to second term gives third term. So adding 3 and 5 will give 8. That is third term. So on so forth. Hence the sequence is 2, 5, 8, 11, 14. And so on. Let us take another example. Here the given first term is minus 1 and the common difference is 0.5. Hence the second term is obtained by adding first term and the common difference. The third term is obtained by adding first term and 2 times the common difference. The fourth term is obtained by adding first term and 3 times the common difference. And so on. Hence the sequence is minus 1, 0, minus 0.5, 0, 0.5 and 1. And so on. Let us see example 3. Here first term is 10 and the common difference is minus 2. So the second term is obtained by adding common difference to the first term. That is 10 plus minus 2. That is equal to 10 minus 2, that is 8. The third term is obtained by adding first term and 2 times the common difference. That is 10 plus 2 times minus 2. That is equal to 10 minus 4. That is equal to 6. Similarly, rest of the terms are calculated. Let us say we are given a sequence of numbers. Then how to find out that the given sequence is arithmetic progression or not? First we should find out the differences between consecutive terms. Then check if these differences are same or not. If all the differences are same, then it is an arithmetic progression, otherwise not. Here is an example. To check whether the following sequence is an arithmetic sequence or not. The sequence is 3, 7, 11, 15, 19. And so on. So first find the differences between consecutive numbers. 7 minus 3 is equal to 4. 11 minus 7 is equal to 4. 15 minus 11 is equal to 4. 19 minus 15 is equal to 4. Now once we found the differences, we have to check the consistency. Here we see that the differences between any two consecutive number is same, that is 4. Hence we conclude that the sequence is an arithmetic progression with common difference 4. Here is an example where sequence is non-arithmetic progression. So we have to check if the sequence 1, 4, 9, 16, 25 and so on is an arithmetic progression or not. So let us first find the differences. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. And so on. Next step is to check if the differences are consistent. That means all the differences has to be same. In this case we see that the differences are 3, 5, 7, 9. Which is clearly non-consistent. Hence this is non-arithmetic progression. If you observe closely, then this is a sequence of perfect square. In this section we note down the important formulas of arithmetic progression. The first formula is for finding out the nth term of an arithmetic progression. Here n is a natural number. A is the first term of the sequence. D is the common difference of the sequence. So the formula is an is equal to a plus into bracket n minus 1 bracket closed into d. Now second formula is for sum of first n terms. The formula is Sn is equal to n divided by 2 into bracket 2a plus another into bracket n minus 1 bracket closed into d, outer bracket closed. Here is another form of summation of n terms of arithmetic progression formula. This formula is in terms of the first term, that is a. And the last term, we denote it as L. So the formula is given as sum Sn is equal to n divided by 2 into bracket a plus L. Please remember here L is the last term. In this section we solve some problems based on the arithmetic progression formulas. Here is the first problem. Find the 10th term and sum of the first 10 terms of the arithmetic progression. The sequence is 5, 9, 13, 17, and so on. Let's first write down given data in the problem. From the sequence we see that the first term A is equal to 5. The common difference can be found out by subtracting two consecutive terms. Here we subtract first term from second term. That is D is equal to 9 minus 5, which is equal to 4. Now write down the equation for 10th term. That is A10 is equal to A plus 9D. Why 9? Because here n is equal to 10. So n minus 1 is 10 minus 1, that is 9. We put the values A and D into the equation. So we get A10 is equal to 5 plus 9 into 4. On simplifying we get 41. Second part of the problem is to find out the sum of the first 10 terms. So let us write down the summation formula for the 10 terms. Then substitute the values of A and D. Here A is 5 and D is 4. So 5 into bracket 2 into 5 plus 9 into 4. That is 5 into bracket 10 plus 36. On simplifying we get S10 is equal to 5 into 46, that is equal to 230. In this section we see some real-life examples of arithmetic progression. First example is saving of money on monthly basis. Say rupees 100 adding every month starting from initially 100 rupees. So every month money will increase by rupees 100. Hence it will be an arithmetic progression with first term 100 and common difference 100. Next example is ladder. Third very common example is sitting arrangement in an auditorium with increasing rows. In this section we are going to derive those formulas which we saw in previous sections. Let us first derive nth term formula. So first write the arithmetic progression in terms of first term and common difference. So let first term be A and common difference be D. Then arithmetic progression can be written as A, A plus D, A plus 2D, A plus 3D, and so on. Now we observe the pattern. We can write first term, that is A, as A plus into bracket 1 minus 1D. Second term is A plus D, which can be written as A plus into bracket 2 minus 1D. Third term is A plus 2D, which can be written as A plus into bracket 3 minus 1D. And so on. From this pattern, we can generalize the pattern in nth term. Hence nth term is an is equal to a plus into bracket n minus 1d. That completes derivation of an term formula. Now we derive formula for sum of n terms of an arithmetic progression. First write Sn in two ways. Sn is equal to a plus into bracket a plus d bracket closed plus into bracket a plus to d bracket closed plus and so on up to nth term, which is a plus into bracket n minus 1 bracket closed into d. Also write in reverse order. That is, begin to write last term first and ending up to first term. Hence, Sn is equal to a plus into bracket n minus 1 bracket closed into d plus a plus into bracket n minus 2 bracket closed into d plus and so on up to plus into bracket a plus d bracket closed plus a. Now add the two equations. That gives us 2Sn on left hand side and on right hand side we add pairwise. That is, add first term of both the equations and make a pair. Similarly, add second terms of both the equations in order to make a pair. And so on. Each pair gives 2a plus into bracket n minus 1 bracket closed into d. Let us see how it is done. Here is shown how each pair gives the value to a plus into bracket n minus 1 bracket closed into d. Since there are n such pairs for n number of terms, hence left hand side will be n into 2a plus into bracket n minus 1 bracket closed into d. Now, divide both sides by 2 and we get Sn is equal to n divided by 2 into bracket 2a plus another into bracket n minus 1 bracket closed into d outer bracket closed. This completes the derivation. There is an alternate method of finding sum of n terms of an arithmetic progression. Let us derive that formula. Last term L is written as L is equal to a plus into bracket n minus 1 bracket closed into d. Now, sum Sn can be written as n divided by 2 into bracket a plus into bracket n minus 1 bracket closed into d. Replace a plus n minus 1 times d to L in the given Sn formula. And we get Sn is equal to n divided by 2 into bracket a plus L. This completes the derivation. In this section we solve problems in arithmetic progression. Find the 15th term and the sum of the first 15 terms of the following arithmetic progression: 4, 7, 10, 13, and so on. The sequence of given number shows that the first term A is equal to 4. The common difference can be found by subtracting two consecutive terms. Here subtracting first term from second term, that is 7 minus 4, which is equal to 3. Now, write the formula for 15th term. That is A15 is equal to A plus 14D. So, A15 is equal to 4 plus 14 multiplied by 3. On simplification, we get A15 is equal to 46. Second part of the problem is to find the sum of the first n terms of the given sequence. So write the summation formula. Sn is equal to n divided by 2 into bracket to a plus into bracket n minus 1 bracket closed into d bracket closed. Now, replace the values of a equal to 4 and n equal to 15 and d equal to 3 in the equation. On simplification, the answer is S15 is equal to 375. The answer is S15 is equal to 375. In this section, we derive the summation of n terms formula using first term and the last term, that is A and L. So first write the arithmetic progression using first as A and last term as L. Hence the progression is A, A plus D, A plus to D, and so on, up to L. We know that the last term L is equal to A plus, into bracket, n minus 1, bracket closed, into D. L is the nth term. Express the sum Sn. Sn is equal to A plus D plus A plus to D plus A plus 3D, and so on. The last term is L. Now, write the sum in reverse order. That is, Sn is equal to L plus L minus D plus L minus 2D, and so on. The last term is A. Add the two expressions such that add first term of both the equation as a pair, then second term as a pair, and so on. This gives n number of pairs. Now simplify each pair. Each pair turns out to be A plus L. There are n such pairs. So the equation is 2Sn is equal to n multiplied by A plus L. Divide both sides by 2. We get Sn is equal to n divided by 2 into bracket A plus L bracket closed. This is the answer. Let us solve a problem in arithmetic progression. Find the sum of the first 10 terms of an AP where the first term is 3 and the last term is 30. Solution. Let us look into given data. The first term, A, is equal to 3. The last term, L, is equal to 30. The number of terms, N, is equal to 10. Here the Sn formula consisting first term and last term is used. So Sn is equal to n divided by 2 into bracket A plus L bracket closed. Substitute the values of n, A and L in the equation. Now, simplify and get the answer. The answer is 165. Our goal is to make education free for everyone. Please contribute to the Free for All Education cause. Give donations whatever is possible to make this journey successful. Since you found this helpful and interesting, please like this video. And for many more courses, subscribe to the channel.